Hello, everybody, and welcome to this Ask Me Anything webinar. My name is Mark, and I'm a technical lead at a company called Edument, where I, among other things, help our clients with implementing React in their projects. And I want to thank you for submitting questions to be answered in this session. They've been wide-ranging. I'll try to group and distill what I consider the most pertinent ones to what I hope to be illustrative code examples. You'll also get a follow-up email with a link to these code examples. So I hope you enjoy this AMA, and let's get started with the questions. So first question is about useEffect, the useEffect hook, and how to think about dependencies. And this question popped up in various forms, and it's all about the linter complaining about dependencies sometimes and sometimes not. It can be hard to figure out why it's the case. So let's try to look at a code example to understand the issue better, which again is that the linter sometimes complained about missing dependencies to useEffect, and sometimes it doesn't, even though it seems that it should complain. Here I have a pretty simple example that allows me to fetch users. And I can select a user ID. And as I step up the ID, the user is fetched. So a very simple app, and the code itself isn't too complicated either. We have a user component where we track the user ID that the user of our app selects. We make sure that we also store the fetch the user data. We have a useEffect where we, based on the user ID, fetch a given user and then update our state with that user data. So as we change the user ID, our effect gets triggered. And remember, useEffect is a hook and a mechanism that allows us to schedule code to so-called effects to be run after the component has rendered. This is typically the case for code such as this, data fetching. And so we can control how often this effect, this callback, is run through dependencies. And so as you can see here, whenever the user ID changes, we make sure that we fetch that user after the component has rendered. So, for example, if we were to remove this dependency, our linter starts to complain that it says that our useEffect hook has a missing dependency. So we either include it or we remove the dependency array entirely. So this works, but in a faulty way. So as you can see, we do fetch a user, but we cannot fetch additional users as we change the user ID because we're not being honest about the dependencies. And remember, this function, this effect, captures, as is common in JavaScript parlance, closes over the current user ID value. We subsequently use that as this entire function is run outside the render. So we need to be honest and correct about our dependencies, and to make sure this works correctly, we need to obey the linter recommendation. So this, I hope, makes sense, that we need to include the dependencies we have in our effect. They need to be present in the dependency list, but other things may not be as obvious. Let's take this function, for example, set user data. It's a dependency in some sense because we're using it inside our effect, but there's no complaint from the linter. Why is that? Well, this function is guaranteed by React when we get it from the call to use state to be the same function across renders. It doesn't change. And since it doesn't change, it doesn't have to be present in the dependency list. It will always be the same. It's not something that can affect when our effect is run. How about this function, API fetch, the function that actually fetches a given user? Well, it's something that is statically imported, as you can see. The linter does recognize that this function is imported, and much like set user data, it does not change from one render to the next. And again, since it's a static value, we don't have to include it in the dependency list. So we only have currently one variable that does change as we increment or decrement the value of the user ID. But API fetch and set user data, those functions are static, will remain the same across renders, and thus we don't have to include them in the list. How about, though, if we make a slight change? Let's say that we're not any longer importing API fetch, but that this component receives API fetch as a prop. So suddenly we made API fetch a prop that is passed to us, to the user component. And suddenly we do get a warning from the linter. And it says that we do have a missing dependency, either included or remove the entire array, but typically we include dependencies that are missing. We also get an additional comment about if this prop changes too often, if this function changes too often, we might consider that we, in the parent component, rapidly use callback. We try to ensure that this function doesn't change too often and thereby affect how often our effect is run. So this slight change suddenly had an, pun intended, effect on our effect code. So this is because the linter right now cannot deduce the nature of this value, the API fetch prop. So it's up to us to sort of solve this issue. So we would have to include it in our list. So what this tells us is that typically what we need to be concerned about when it comes to dependencies to useEffect is props and states or states. So props and state are typically things that we use in our effect. And as such, we will also have to concern ourselves with their inclusion in this dependency list. So that's sort of a rule of thumb for our how we deal with dependencies. Let's try another thing here as well for illustration. Let's say that we create a function that looks like this. we add a little logging function, LogUser, and let's call it inside the effect. So the linter now complains. We have a missing dependency, LogUser. This might be self-evident or it might not, because it's a function, so it's not too complicated. It's not state and it's not a prop. But what we do have here is a scenario where our function, LogUser, which is created every render, captures the value of user ID. It closes over it. So when the LogUser function is called in the effect after the render, sometime in the future, we will have a specific value of user ID that is being logged. And since we're actually using user ID inside LogUser, the linter recognizes it and tells us that even though it might look like a simple function and then itself is not a proper state, you're actually using state inside it. So make sure you include it. And this is even though we're already depending on user ID. That's beside the point. We still have to include LogUser as a dependency, as it itself uses a prop. So this might be a somewhat a nagging concern. How do we, is there a way around this to avoid adding it in the dependency list? Well, if this is the only place where we're actually using the function, the easiest thing is just to, let's just add it inside the effect, and we solve the problem. But this means that it can't be used in other parts of our component, maybe in other effects. If that would be the case, we could simply put it outside the component entirely, but we could add a parameter to it. And then we could invoke that function. And now LogUser no longer captures the state, the user ID state. It gets it as a regular function parameter. LogUser itself is a static value that does not change between component renders. And as such, the linter no longer complains. So as a rule of thumb, again, what you typically end up having in this list of dependencies is props or state. And sometimes you have things that in turn use props or state. Then they have to be a part of that list. There are then ways around this and try to simplify this list. You can move things outside a component, make them static values, allowing the linter to, or ensuring that the linter no longer complains. Okay, that was hopefully a somewhat helpful overview of useEffect dependencies. Let's first see the next questions that I received, which was, how do I debounce props? That took a bit more of digging, and basically the scenario for this question is that we have a parent component where a user can enter an ID in an input. Very much the example we have right now. And this ID is then passed to a child component as a prop, where we use it to fetch something, an entity. Again, much the same that we're doing now. But the questioner was concerned that as the user was changing the ID too frequently, it led to the subcomponent, the child component, being re-rendered too often, and we have got excessive fetches. So we wanted to avoid that. We wanted to allow the user to sort of select a user ID with some delay. So we await the user's final ID selection before we actually fetch something. And this sort of delaying of actually fetching something is termed debouncing. So basically, it's a technique where we delay the action taken upon user inputs. So we try not to do things too frequently as the user input changes. So I'm going to answer this question, but we're going to use a state instead of props, but the concept is the same. We have a scenario right now where, as I change the user ID, you can see that we fetch all the user ID that I step through. My wish is that as I step through and then land on a final user ID, that would be the only one that we fetch. So instead of fetching all the intermediate user IDs here, I only want to fetch the final one, which I select, meaning user ID number 9. So let's see how we go about achieving that. We talked about fetching user IDs or selected user IDs too often. So we have here a handle, change handler, event handler, which is invoked every time I change the value in my inputs. And I'm setting that user ID. And therefore, as I set it, my effect is run. So thinking in a sort of straightforward way, there is something about delaying this update of the user ID. We want to allow the user to step through, and then when he or she lands on a final user ID, that's the one that we choose to update our state with. And that's the one that we then fetch as well. So what would it mean to delay this function call? Well, we would delay something, of course. We would delay the fetch, but the problem is that if we do not invoke this function immediately, we won't be able to see that user ID that we step through in our input. We will simply be stuck on ID number 1 for a while until I stop stepping through IDs, and then we fetch. But I want to see all the IDs that I step through. So the most straightforward way to just delay or debounce this function call won't solve the problem. In these scenarios, it's helpful to think about not only the state that we have, but what kind of additional state that we can derive from it. So yes, we're showing user ID and we're tracking the user ID state. But what we really want to do is that we want to use this user ID as the basis for a URL to fetch an actual user. So we can add additional state besides user ID to our component. I'll call it resource. For now. So we have apparently some sort now of resource state. And in addition to setting user ID, we're going to set, I have here a function that I call set user. And I'm going to call this with the URL of based on my user ID. What is set user? Set user is going to be a function that looks as follows. So set user is a debounced function that takes a resource, this URL, and updates it. But we delay this by 1 second. So again, in addition to setting the user ID, we are setting the URL, the resource that we want to fetch, and this is separate state. And setUser is a function that does this. We're setting the new resource to fetch, but it's something that's going to be delayed for 1 second. So this debounce function, which is coming from a library called Lodash, which we need to import as well. This function will update the resource state, but slightly delayed. The problem, however, is that this is not sufficient, because this function is created every time that this user component executes, every time it renders. So if we just leave it as is, we'll end up with multiple debounce setUser functions, which is not really the behavior we're looking for. So what we need to do is we need to create this delayed function, this debounce function, and we need to save it for future use. So whatever we get back as a result from this invocation needs to be saved for us to invoke in handle change. And this is called memoization. We need to memoize the return value from this debounce call. And there is such a hook in React that we can use for this purpose. It's called useMemo. useMemo. And useMemo looks as follows. We provide useMemo with a function that returns the value that we want to save for later. And what we want to save is exactly this delayed function. And much like useEffect, it also accepts a dependency list, but we don't have any dependencies right now. So we only create this debounce function once, and then we're good. And we need to import useMemo as well. So what we get here is a function that is saved, memoized for future use, and the function will be debounced, delayed. So when we change the user ID, and we also set the new URL for that user ID, this call will be pushed ahead to the future by 1 second, so to speak. So it doesn't happen immediately, which means that as long as the user starts stepping through the user IDs and it takes place within 1 second, we will not fetch those users in between. So this is more or less what we need to include to make this work. So let's see what we end up with. Oh, well, of course, there's one major thing still missing. We need to change our useEffect, of course. So right now, we're no longer depending on user ID, we're depending on the URL, the resource. And we're going to change the invocation a little bit. We're going to say that we're fetching the resource in here, resource, and then we're going to update the user data. And then we can skip this function as well, so we end up with something similar. There we go. So to recap, we are creating a function called setUser, which is created once and then saved for later use, which delays updating the resource state by 1 second. We use this setUser in our handle change event handler, but we call it, as you can see, with a URL that we create based on the user ID. And then our useEffect now depends on the URL, not the user ID anymore. And we use the URL to fetch our selected user. So let's see what this gives us. We're fetching users, but as you can see, as I navigate, we're no longer fetching all the users in between. We're fetching the user that we end up with. So we sort of got the behavior that we were looking for. Where we earlier had a lot of fetches, we now have only the ones that we actually conclude with. So we're debouncing the fetches as the user steps through the values in our inputs. So that's how we debounce things in an example of debouncing in our application. Okay. That took care of our first two questions. The linter complaining about useEffect dependencies and how we debounce props, or in this case, how we debounce state as the state is changed and we need to do something based on that change. The next part of this session is about RxJS. I got a simple question that simply read, how do I use RxJS in React? This is kind of a broad question, but it's an interesting one, and it provides a reason to code the example that we just had in a slightly different fashion. So I wanted to go through that as well. So what is RxJS? Well, it's a subject that is probably, well, is too big in scope to detail in just a short session like this, but it's a library that we can use in our apps to work with a sort of reactive style of programming, a slightly different paradigm than we're used to. And the core of RxJS is what's called the observable. And observable can best be described when compared to a promise that we have in JavaScript. So we know that a promise is a one-off event. It's something that occurs in the future and then it's done, either successfully or maybe something that occurred failed. So a promise is something that occurs once in the future and then we're done, whereas an observable is a collection of events, multiple events in the future that in theory never stop occurring. So we have something that produces events over time that we can subscribe to and handle in the future. So maybe view it as an extended promise. So this is sort of a way of working with streams of data and act upon those streams as data. We receive data from it and do some action. Another part of RxJS that's important is what's called operators. So those are sort of common operations that we normally have when we work with arrays, lists. But as we are dealing with a collection of events over time, you can view it as a list of events over time. We can apply similar operators to that list, that stream. So it feels natural to work with, much like that we would use with normal lists, normal arrays. And we have operators such as map and filter that we can apply to these streams of events or streams of data. To further illustrate this concept, let's look at some diagrams. So this is a helpful site which allows us to view this observable concept with some more intuition, hopefully. So here we have an observable that is producing a stream of data over time. So on the horizontal axis, you see the flow of time, and we're producing 10 different data items over time from this observable. And here at the end, if we were to subscribe to this observable, we could operate on these events, these data items, in a way that makes sense to us. So basically, we have things occurring over time, and we can subscribe to these streams, these collections of events or data, and do something interesting with whatever we receive over here on the right-hand side. The case that I'm interested in is was one of the final questions here. What is an example of a scenario where RxJS is actually useful, besides being a nice theoretical concept to talk about? What scenario is it useful for, and how do I implement it in a component? So remember our debouncing example that we've been looking at? Let's see how we can use RxJS to implement the same debouncing example, but using RxJS instead. So here you see a stream of events, again, over time. So this might be our user IDs. Here we have the first one that the app fetches, and then the user steps through user IDs in quick succession until he or she selects or lands on user ID number 6, and that's the one that we want to fetch. So you can see that the user is not selecting user IDs in a very structured fashion with equal time between those selections. This would probably mean that I'm stepping through user IDs rapidly until I end up with user ID number 6. What we want to do is we want to debounce again this input. So we start with user ID number 1. If we happen to step through quickly a number of user IDs, we're debouncing and dropping user IDs that are not of interest to us, namely number 2, 3, and 4, until we end up with number 5. And that's the one that we continue with. And then more time passes, the user selects number 6, and that's the one we fetch as well. But ones that are input too quickly, those are the ones that we forget about or debounce and drop. So this is a scenario that would be important for us to implement if we want to have debouncing in our app, but with RxJS. So basically, we're treating user IDs and the changes to it as a collection of events that we subscribe and operate on. And what would that entail in code? Well, let's look at that example. So I'm going to switch to a similar but slightly different example. So here we have the same user component again, starting out from scratch. And I'm going to add a bit of code. And again, this is not a tutorial on RxJS. It's more of an example of how it can be used in React. So I'm going to make sure that you get a link or several links to useful resources so you can acquaint yourself in more detail with RxJS. But for our purposes, I want to illustrate how we add a little bit of code, restructure our component, and how we, in my estimation at least, do simplify our code quite a bit. So I'm going to start off by adding what's called a subject. A subject is an observable. It's something we can subscribe to. It's something through which events flow over time, but it also allows us to pipe things into it. So we can emit things through the subject on one end, and then we can subscribe to what we get on the other end. So we create an observable called source. This $sign at the end is more of a convention to tell people who look at our code that this is an observable. This signifies that we are working with observables. And I'm going to add a little bit more of code here. And I'm not expecting it to make sense immediately, but I'm going to show in a short while a diagram of what this means. But basically what we're doing here is we're taking our observable, our stream, we're splitting it in two streams. In the first stream, we're only getting the first data item, which is the user ID number 1. In the other stream, we're skipping the first one, but we're handling all the other events that we do receive, and those get debounced. We then merge these two back again and switch from having a stream of user IDs to getting a stream of actually fetched user data. Again, don't worry about the details. I'll try to illustrate it a bit more helpfully soon. But this is something that we create to operate on whatever streams through our observable, which is, again, user IDs. And we're adding a bit more code that changes the way we work with the user ID values. So now, instead of having additional state that we had earlier called resource, we're just setting the user ID, as you can see. And we have an effect that, additional effect, that based on the user ID simply adds it to the source observable. So we're emitting, piping user IDs through this observable. And then instead of this effect, we're going to have another effect that subscribes to this observable. So when we start up our component, or it's rendered the first time, we run an effect which subscribes to not the source, but the thing that is called merge, this merged observable. We subscribe to it, and what we get is user data, which we update and then render our component with. This is a lot of code that probably doesn't make too much sense right now, but I want to zero in first on this part. We have a source observable into which we can pipe user IDs and then subscribe to on the other end. And we also, from this source, create something else. And I want to show you what this something else means. So here we see, again, over time, we are piping or emitting URLs as the user changes the user ID. So this line that said source.next, into which we pass a URL, is what we're doing in our event handler. And I'm sorry, in our effect here. So we update the user ID, and then we pipe that user ID, but as a URL now, to our observable. So this line is into something into which we pipe URLs. So that's what's happening there. From this source, we're splitting this stream into two. We have one stream here and a second stream here. So these two are two streams that have been, they're based on the source, but as you can see, we've split it into two. The first stream only cares about the first URL, namely user ID number 1. That's the one that we fetch by default immediately when our app renders. The second stream, as you can see, is a debounce stream. So as the user changes user ID and we add URLs into our stream, these get debounced, these get delayed. When we merge this stream and the next one, basically from the source, we get the merged variant that looks like this. We handle the first user ID as we always do. We just fetch that user immediately. But as the user then changes user IDs, we fetch, but in a delayed, debounced fashion. And from this stream, we finally switch over to get a stream of actually fetch the user data. So there are a number of steps occurring here where we operate and work with these streams. And that's a bit of manipulation because we have certain logic where, again, the first user ID should just be fetched immediately, but all the other user IDs afterwards should be delayed a bit. So this looks a bit different, I hope, probably as you observed. We're not memoizing anything. There's no use memo hook that we use. This handle change is, well, easier. It didn't change at all. We didn't add extra state. There's no resource state that we had previously. What we're doing here is we're creating a stream into which we can pipe URLs. And then we subscribe to not URLs, but the data that's been fetched using the URLs as a basis. So you can consider this line is what we have to the left of the stream. This is what we're doing sort of on the left-hand side. And then we subscribe all the way over here in our useEffect. So we start off by piping in URLs. We end up receiving fetched user data. And the magic occurs by virtue of this observable and some workings with in the workings of operators. And this line, the bounce time, is all that is needed to implement debouncing. It's an operator that makes sure that we're debouncing the data that flows through our stream. And it's a much easier approach in my mind than what we had to do previously. So this is somewhat different than what we're used to because we're not used to working reactively in our code. At least I haven't been throughout most part of my career. But it takes a bit of getting used to because we have to start treating the data that our app relies on as streams or being emerging, flowing through streams. And we operate on those streams to get our desired result. But it turns out that our code, in many cases, gets simplified, often by a lot, and gets easier to reason about. And we, as in this case, don't have to resort to some what people might consider hacks with use memo and memoization to achieve a result. It's just a different way, different paradigm in how we structure our code. But in cases such as this, where we do have naturally occurring streams of data, we allow the user to select the user IDs over time and change it. And we have something emerging as a result from that, to structure our code around that kind of thinking, well, it leads to at least the way I look at it, as better code, and more importantly, better architecture, or better software architecture. So if you do have some free time on your hands and you're looking for something important or fun to learn, I highly encourage you to look more at RxJS. And I'm thankful that I got the question, because it was a good demonstration of RxJS and how it might be useful in a scenario such as this. I think I'm gonna end the session there. There is an additional example, but which I can sort of describe with some notes in the link you'll receive after the session. So I'm going to leave it for now, but please do look at it if you find that interesting. It's also about useEffect dependencies, but we already covered that. So I'm going to end the AMA on this note. So I want to thank you for attending. And again, you'll get a follow-up email with the code examples and the additional links to RxJS and other useful information. So I hope you enjoyed it, and thank you for your attention.